Observe the students organized in queues for a school assembly. You can see that in every column that represents a class, the height of the students increase from the front to the back. You also see a decrease in height from left to right in each row, which consists of students from different classes. A similar gradation is seen in the properties of elements in the periodic table. You can observe regular changes in the properties across periods as well as down groups. In this lesson, you will learn about periodic properties and the trends of periodic properties across a period and down a group. At the end of this lesson, you will be able to define the term periodic properties, explain the significance of periodic properties, and describe the trends of periodic properties across a period and down a group. The term periodic properties in elements refers to the properties that recur at regular intervals. The trend of recurrence of properties is called periodicity. The important periodic properties of elements are atomic radius, ionization energy, electron affinity, electronegativity, and metallic and non-metallic character. We will look at each of these properties in detail to find out how they vary across a period and down a group. Atomic radius is the distance between the center of the nucleus and the electron present in the outermost energy level or orbit of an atom. Atomic radius is expressed in angstrom units. 1 angstrom equals 10 to the power minus 10 meters. Let us now analyze the variation in atomic radius. Atomic radius decreases across a period. This happens due to the addition of a proton to the nucleus, which increases the positive charge. This pulls the valence electron inwards, resulting in a decrease in the atomic radius. Fluorine, a halogen atom, has the smallest atomic radius of 0.72 angstrom units. On the other hand, atomic radius increases down a group. This is because when you go down a group, electrons enter a new principal energy level, and the number of shells in the atoms increase. Therefore, the size of an atom increases down the group. In the periodic table, cesium, Cs, an alkali metal, has the highest atomic radius of 2.62 angstrom units. The second periodic property is ionization energy. Ionization energy is the minimum energy required for removing the outermost electron from a gaseous neutral atom to form a cation. The unit for ionization energy is electron volts, or kilojoules per mole. An example of ionization energy can be observed in reactions involving sodium, where 496 kilojoules of ionization energy is needed for the formation of a cation. Let's now review the variation in ionization energy. Ionization energy increases as we move across a period from left to right. This is because the decrease in atomic size results in an increase in the nuclear attraction, thereby increasing the ionization energy. This is why inert gases possess the highest ionization energy. Helium has the highest ionization energy in the periodic table. Down the group, the ionization energy decreases due to an increase in atomic size. In the periodic table, alkali metals possess low ionization energies. Cesium, an alkali metal, has the lowest ionization energy. Next, let's look at the third important periodic property, electron affinity. Electron affinity is defined as the energy released when an electron is added to a neutral gaseous atom. The unit for electron affinity is kilojoules per mole. Consider a fluorine atom In the gaseous phase, a fluorine atom releases 328 kilojoules per mole when it gains an electron to form a fluoride ion. Let us now observe the variation of electron affinity across a period. Electron affinity increases from left to right in a period. This occurs because across a period, the tendency to gain electrons increase with a decrease in atomic size. Halogens in the periodic table have the highest electron affinity values. Electron affinity decreases down a group. This is due to the tendency to gain electron decrease with an increase in atomic size. The zero group elements or the inert gases have the lowest electron affinity values in the periodic table. Generally, electron affinity values are negative because electron affinity involves the release of energy. Let us now talk about electronegativity, the fourth important periodic property. Electronegativity is defined as the tendency of a bonded atom to attract the shared electron pair towards itself in a molecule. Note that this property is observed only in the atoms in a molecule. Let's review the variation in electronegativity in the periodic table. Across a period, electronegativity increases from left to right. As smaller atoms are more electronegative than bigger atoms. In smaller atoms, the outer shell is very close to the nucleus, and hence, the attraction between the nucleus and the electrons are stronger. In the periodic table, halogens have high values. Fluorine possesses the highest electronegativity value of 4.0 in the periodic table. Down a group, the tendency to attract the electron pair, or electronegativity, decreases as atomic size increases. In the periodic table, alkali metals possess very low electronegativity values. Cesium has the lowest electronegative value of 0.7. The last important periodic property is metallic and non-metallic character. Metallic character is defined as the tendency of an atom to lose electrons. The tendency to lose electrons is due to low electronegativity or high electropositivity. Non-metallic character is the tendency of an atom to gain electrons. Now, observe the variation in the metallic and non-metallic nature of elements in a group and in a period. Across a period, metallic character decreases and non-metallic character increases due to an increase in electronegativity. So, the tendency to lose electrons or metallic character increases. For example, cesium has the most metallic character and fluorine has the most non-metallic character. Down the group, the metallic character increases or the non-metallic character decreases. This is because the increase in the atomic size decreases the electronegativity, which increases the metallic nature or decreases the non-metallic nature. From the trend, you can make out where the metals and non-metals should be positioned in the periodic table. Metals are placed on the left of the periodic table. Non-metals are placed on the right side. And metalloids are placed between the metals and the non-metals.